Good morning, everyone. Thank you for joining EAC's webinar today. This is Addison Tyne. I am the marketing specialist here at EAC. We will be recording the session today, so pending any technical difficulties, everyone will receive a replay of the webinar. Please feel free to drop any questions in the queue, and we will get to them after the presentation. Following the session today, a short survey will appear, so please stick around and answer those questions after the webinar. Today, I'll start off with a short introduction of EAC, and then our technical account manager and Creo expert, Todd Liebenow, will be diving into Generative Topology Optimization extension in Creo. And Todd, if you want to go for the next slide. At EAC, our mission is to transform the way companies design, manufacture, connect to, and service the products. And you can go to the next slide. We are located all over the United States, and our headquarters are currently established in Minneapolis. You can go to the next one. We are more than just a value-added reseller for PTC, though. For over 20 years, we have helped companies innovate their product development processes. With experts in 22 different areas of product development, we help organizations create better products, rethink what may seem impossible, and ultimately achieve results that make a lasting impact on the world as we know it today. Beyond helping organizations connect to the information they need, we also work with companies to connect their enterprises, as well as specific focal points which produce bits and pieces of their operational value. You can go to the next slide. We also assist with design and engineering products, host educational webinars, and PTC certified training courses. And then the next one. Aside from that, we have partnered with Formlabs, which also allows us to offer our customers with some of the latest and most affordable 3D printing options in the industry. All in all, we want you to know that EAC is a company to get all the technology at the forefront of your business to help make your team successful. Our niche is helping you figure out where to start. Our specialty is helping you to build on what you already have. With that, I'm sure you've heard enough of me for now. I'll go ahead and hand things over to Todd so we can learn more about generative topology optimization in Creo.
All right, good morning, everybody. So we've got a bit of an agenda here. We'll just take you through this. We've got a couple of slides to kind of flesh out the details of what this generative topology optimization stuff is and what it looks like in the software. Let's first talk about some challenges, and then we'll look at the solution and capabilities, and then get into the demo. Sorry about that, I just hit the mute button instead of the page down. So first things first, let's talk about some challenges, right? So product development today requires differentiation to help you be relevant and competitive in the marketplace, right? So we're looking to develop new products, and we want to be able to say, hey, this is why my product is different, it's better. Some other reasons that we have some challenges here is that subject matter expertise, right? So you've got quite a range of skill sets between new hires and interns and engineers and designers that have been doing their thing for a number of years, and you've got a gap in the skill set between your people. Well, maybe there's some technology that we can leverage here to help get everybody kind of up to speed and more functional and more quickly as far as developing new products in a shorter amount of time. And that's the point, right? We want to do more product designs, more iterations, get better products out the door, but there's never enough time to get it done. So how are we going to address these challenges? Well, PTC has this generative topology optimization, right? So we're going to just abbreviate that as GTO. What we have here is some new capabilities that allow us to autonomously create more optimal designs based on some design requirements, things like boundary conditions that you might be familiar with in analyses, your loads, constraints, materials, but then also the manufacturing process. We can consider that as a function of the generative topology optimization. So what we're going to do is take a look at using this generative topology optimization and some new functionality in Creo 7, and we can look at different ways we can optimize the design by just specifying some of these boundary conditions in manufacturing processes. So it'll allow us the tool sets to explore some traditional manufacturing methods, like looking at extrudes or extruded features or machine type features. But we can also consider new technology like additive manufacturing. So things like 3D printing and whatnot, those capabilities, we can design our parts now and take advantage of those new capabilities. So what we're looking at here is the ability to explore different design solutions, looking at critical loads, materials, different manufacturing constraints, things like that. And we can define several different generative studies to explore different alternatives and look at the results and help us use the software. It will help us understand what the optimal part can look like. And then we can look at real-time design generation when the input geometry is being modified. So what we're looking at here is a more optimum design based on some loading conditions and how this part is actually going to be used in the real world, and sort of figure out what does the optimal part look like. So this is sort of looking at some simulation results from that. We can take a look at things like stress and displacement and help us understand, how is our part going to perform? How is it going to behave based on this new design that GTO has built for us, and we can evaluate different results. And of course, because we're built inside Creo, right, we can make changes to our design and have these changes kind of propagate through the design, and our generative design can update and respond to those changes that we made. Again, it's associative, right? Because it's Creo. It's just the nature of the way that the application works. So what is this? This is topology optimization. A couple of years back, maybe a little bit longer, PTC acquired a company, Frustum, and they had this technology for generative design. Well, this is fully incorporated now inside Creo 7. So this is functionality that is going to be available in Creo 7 and going forward. At this point, it's not going to be integrated into any of the previous versions. So it is something that's going to be specific to Creo 7 and newer versions. But what we'll do here is take a look at this integrated functionality inside Creo, and how do we use that, and how do we actually get this optimum design. So the process, like I said, is integrated. So it's very similar to what you might do in Creo Simulate Live or Creo Simulate with respect to defining the loading for your part, right? So you're going to have material, you're obviously going to have geometry, and then from there you would assign a loading conditions. You apply a load to a part, and you're going to constrain it or hold it in place. And then you also have the ability to put in manufacturing conditions, right? So it's just going to be a machined kind of part. Is it going to be an extruded kind of part? Will it be 3D printed? Those types of things. And what will happen then is you'll define this boundary case, boundary conditions, and the software then will go out and figure out what does the optimal geometry look like based on the scenario that you've presented. So from there, you can output the results to create the geometry, that optimized model, and then from there, if you want to do further refinement or analysis on it, you can take that into Creo Simulate or Creo Simulate Live to do the further studies. So again, you're going to see quite a bit different part geometry than what you might used to, or what you're probably more familiar with. It looks almost organic in a way with the resulting geometry that the generative topology optimization creates. So again, we've another toolset that we have here is deviation analysis. So this will allow us to compare both visibly and numerically the difference between the created boundary representation geometry back to the triangulated geometry. So again, more details will come out as we actually do the demonstration. But what's going to happen here is you're basically doing an analysis on this with an internal mesh that's going to do the computations and figure out where do I need to have material and how much material do I need to have, and it'll create this sort of triangulated geometry. And from that, it's going to wrap that geometry with a Creo freestyle type feature, which can then be solidified to give you the resulting final geometry. And here's an example of what that deviation analysis can look like. So it's kind of measuring the differences there between the two different versions of that part. Okay, with that, let's go ahead and put PowerPoint away, and let's take a look at what this looks like inside Creo. So what I've got here is a model of a front suspension for a motorcycle. And specifically what we're going to be looking at is this part here that's in the center. And if we kind of take a look at this, we've got some views. Let's go ahead and take a look at our start view. So we're kind of focusing on this part. And it looks like it's maybe a cast part or a machined part, something like that. And if we kind of roll this thing over, well, we can see that we've made some sort of attempt at lightening up the part here. We want to, take some material out the back side of the part here. But again, we're not real sure, is that gonna be enough? And then if we removed enough material, have we made it lighter, or light as it can be? And then we potentially need to do a structural simulation on that. Is that going to be, is it going to perform the way that we want? So let's go ahead and kind of focus in just on that one part. So let's go ahead and take a look at our starting model here. And so we've got a sort of a simplified starting version of that. We have the basic shape that's defined by our mounting locations for the steering column here, and then the shock absorbers on the side, and then our mounting locations for the holes. So we know that that's our starting geometry. We're going to start there. Another thing to note here in Creo 7 is this notion of bodies. So if you take a look here at what we have in the model tree, we have the different bodies, and again, this is new functionality in Creo 7. So I can create different protrusions, different extrusions, or different pieces of geometry. The same way I did before, I can do that with the sketch, but I can define that I want to have that be as a separate body, and then I can do different things with that. So I've got a couple of different bodies in here. We have our envelope, which is going to be the outer boundary of that. The entire part, and then we've got our preserved geometry here. So if I go ahead and let's hide that out so you can kind of see what the difference is. This is the preserved geometry. This is the geometry that we know that we want to retain because we have to mount up to the different locations here. The steering column and the shock absorbers have to have that geometry there. We go ahead and kind of flip this and show the other geometry. This is the region of the part that we're going to do our optimization inside of. So we have those two different geometries kind of set up. So that's our challenge, is to figure out how can we make this part as light as possible and have it still perform the way that we need it to on the motorcycle. So in the applications tab up here in the ribbon, we've got this generative design. So just like everything else in Creo, the ribbon works or helps us through the process, and it starts on the left-hand side and works to the right. So the first thing we'll do here is go ahead and define our starting geometry, and we'll go ahead and pick our in this case, we're going to pick our envelope. So we're going to keep that. We're going to start with that. Then the preserved geometry, that's what we want to maintain here. We'll go ahead and select that, and we'll just go ahead and pick on our preserved geometry for that. And so now we can see we've got our geometry basically defined. There's one other option here, excluded geometry. I've got another model that we can kind of talk about that in a little bit, but that defines a region of the model or volume of the model that you want to exclude or not build any resulting geometry in that area. It's not applicable for this model, but I've got another case here that we can take a look at and show you how that works. Next, it's really very similar to setting up a structural simulation. I'm going to go ahead and define some constraints. I'm going to hold the center portion there. We'll go ahead and lock that in. And then we define some loads. So I'm going to go ahead and pick on the two cylindrical surfaces here. And you might notice this is a little bit different here in Creo 7. We've got a nice new dialog box here with some new functionality for helping to set up the direction of our loads. And I'm going to pick the directional components here. And we're working in metrics, so I'm going to make sure that we're applying this in newtons. And the force that we're going to apply here is going to be 5,200 newtons in the x direction, 5,200, and we're going to specify 3,000 newtons in the y direction. And so there we've got our load applied. So so far that's very similar to what we would have done in a Creo Simulate or Creo Simulate Live sort of an analysis. But we've got a few more steps. It's easy. We'll go ahead and take a look at our design criteria. And here's where we start to specify additional details for the optimization. I'm going to set a goal here of 67%. I want to go ahead and limit the volume of that original part to 67% of its original volume. And now I'm going to define some constraints. If you think about this part, I really need it to be symmetrical, sort of left to right. And I've got that option here. I'm going to go ahead and say I'm going to pick planar symmetry. And the actual datum plane that we're going to use for that is going to be the front plane. So it actually slices that part in half, left to right. And then the next thing I'm going to do here is define some material. So I'm just going to go out to my library and we'll go and grab, let's see here, we want let's go grab an aluminum silicon copper cast material. We'll go ahead and pick that guy and we'll go ahead and apply that. So again, very similar to a simulate analysis. Go ahead and select OK. And now we're going to pick on our study settings. So this is where we're specifying things like the element size and the number of iterations that I want to go ahead and use here in this case. So I'm going to just specify an element size here of 2.96926 millimeters. That says that's the maximum, the biggest the element can be for that. So we'll go ahead and take that, and then we'll go ahead and optimize that. So it'll take about a minute or so here. If you kind of watch what's going on here in the part, you can kind of see that right here in the upper left-hand corner of the graphics window, it tells me that it's optimizing. You can start to see that it's going to build in geometry there as those webs kind of are grown, if you will, inside of that area or volume of the part. So it's about a minute plus or minus or so here for Creo to finish the calculations and build that geometry. And there, we're done. So we can go ahead and take a look at some of the simulation results. Go ahead and take a look at that. And again, new functionality in Creo 7 as far as the legend, and you know, it's really easy to use as far as looking at the results. In this case, we're starting off looking at the von Mises stresses. Right, so you kind of get an idea of what that looks like. Down here, I can pick on the minimum and maximum. I can see that the minimum and the maximums are at those different locations right there. If I want to turn that on as a probe, I can go ahead and have that be displayed so I can keep track of what that maximum value is. Additionally, if I want to look at instead of stress, we want to look at displacement. I can do that. And if I want to animate that, you can go ahead and take a look at those results. So now I can get an idea of how that part. So not sure, you know, animations don't always play real well across these web meetings and stuff, but we can, you know, speed up the display here and kind of see how that part is sort of deflecting based on the load that we have. All right, so that's a quick look at some of the results we have. We'll go ahead and close that and go to the next step. So after I've taken a look at my results, the next step in the process is to go ahead and generate that design. So we have this resulting sort of optimized geometry, but let's go ahead and take a look at the next step. We're gonna make a new part from this. So I can either keep the resulting geometry inside of this part, or I can make a brand new part from this. And I've got a couple of other options here too. I can say keep this tessellated model, or I can go ahead and create a boundary rep or a BREP version of that part. We're going to take the BREP version. We'll just generate that. I'm going to just take the default name here for that for now. And again, another minute or so here. And what Creo is going to do is create that new geometry for the web inside there, and give me a feature that I can do other things with inside of that core base part. So while this is running, is there any? I'll take a minute here and pause, Addison, if there's any questions from the audience at this point.
I don't see, one sec. Mark just asked, can you blend or add multiple stress vectors into the final solutions?
Let me make sure that I understand the question. If I said it a different way, would it be having multiple different load cases? So if I had two different load inputs, or multiple different load cases, you know, if I want to have a couple of different scenarios that I'm looking at, the answer to that is yes, right? So I can, assuming that that's the question, and if there's clarification, I can certainly.
He said yeah.
Okay, cool.
That's what I meant.
Yeah, I appreciate that. It's hard to, you know, ask and answer questions sometimes over these web meetings, but yes. So the short answer is absolutely. Yeah, you can have multiple different load cases, and you can do your optimization once, and you can incorporate the results from that inside one model. The other model that I mentioned before with the preserved geometry or the excluded geometry does show that exact scenario. So we'll get to that in a couple minutes if you can hang on. Okay, so we've created our resulting geometry, and then we can see we have this construction group here. And so really what we have here is, if we take a look at this construction group, you can see that ultimately there's a regeneration feature, and down here we have a solidify. So the last step in the process would be to go ahead and say, we've got new functionality here in Creo 7 for Boolean type operations. I'm gonna go ahead and grab that center portion, and I'm gonna merge that into that part. So before it was, you know, separate pieces of geometry, but now I'm going to basically fuse them together, so I have one set of geometry there that is that final body. Everything is kind of all fused and merged together. So from there, if I wanted to do a Creo simulate study on that or something, I certainly can. Or if I needed to go back and make a design modification to that, maybe change the diameter of this hole or something like that, I could do that too. So let's go ahead and take a look at that. What does that look like here? So I'm just going to go back and take a look at this layout. And if I want to make a dimensional change to that, if I want to change the diameter of this outside feature here, I'll just go ahead and do that. I'm going to change that from 58 millimeters to 54 millimeters. We'll kind of shrink that down and just do a quick regeneration on the model. And then I can go back to my design criteria. We can say, hey, you know what, I want to change this and make that be 70%. And if I want to go back in and add some constraints, let's take a little bit different look at this. The first time we looked at ran the model, we said, hey, let's look at this from an additive manufacturing or 3D printing scenario. Let's look at a different option. I'm still going to use my planar symmetry. So I'm going to go back here and pick my front plane as my point of symmetry. And I'm going to add another constraint now. In this case, I'm going to say, let's make that be a linear extrude. And I want to extrude it in the direction of that top plane. Okay. So then the next thing I need to do is just specify the materials, right? So I still have this one. I can pick on this material, right? We'll say that we're going to use that guy again. And so now I've got my situation set up here, right? So again, what have I done? I've set my design limit of 70% of the original mass or volume of the part. I've defined this is going to be a linear extruded type feature instead of a 3D printed type feature. And again, I'm retaining that mirror symmetry across the midplane of the part. So again, I would go ahead and just do the optimization on that. Again, it takes about a minute to do that, but in the interest of time and this morning, I've got a model here that we can go ahead and open that up. So just go ahead and open that. And that's going to be the BREP model here. So here's that extruded version of the part. So this is the net resulting geometry that we ended up with, right? So you can see the center portion of that. Quite a bit different from the last model. I don't have those sort of organic ribs that go from one point to the other. You can think about this as being linearly extruded in the direction of the plane of that part. And again, that gives me an optimal solution in that case. So same as before, we'll go ahead and pick on this Boolean operation. We'll merge those two features together. Okay, and there's our fused part. And the nice thing about this is the boundary conditions that we apply for our optimization can be leveraged inside Creo Simulate Live. So again, I've just toggled into the Creo Simulate Live functionality. We'll go ahead and click Simulate on that. I don't have to reapply the loads and boundary conditions for that. You can go ahead and just run that simulation. Take just a minute or two here. We'll pull open that information. We'll start to look at the results from that. Okay, and the other thing to note here is that we have performance options here, and I've got this already cranked up to maximum accuracy on that. So you can see there that we've got a nice structural simulation on the part at this point. Okay, so that's a simulated version of that part. Any questions at this point? I feel like I'm kind of racing through this, but want to pause and make sure that there's any questions we can address them.
I don't see any. Mark kind of put a last minute question in there. I think it had to do with the last one he asked. He said front forks have to take stress in multiple load cases, ...
Yep, exactly right. Yep, and that's certainly something that's a capability inside. Again, it's just back to your, if I drop out of here to the application for that. So you'd have in the generative design, you could have multiple different loads for that, right? So that's just a definition of your generative design. So you can have multiple different load cases. So here you have just this first constraint, and then you have just one load set here. If you wanted to create another load, you can add another load case and then different loads and constraints based on that. So very similar to what you have in Creo Simulate or Creo Simulate Live. So you can have multiple different load cases at any one time. Let's see, then the last thing, just to kind of take a look at a different version of that model. If I have a interchange assembly here, so this is 3 different versions of this part. And if we go ahead and turn on the annotations for that. So our original model weighed 885.85 kilograms, and we have a second one here, 0.786 kilograms, and we have the last model we just looked at, 0.860 kilograms. And so we can see that we've got lighter versions of that. And this is what's called an interchange assembly. So what I can do is assemble in different versions of this component in the assembly. And then what happens is back at this top level here at this assembly, I can go ahead and pick on that component, and it opens up in the model tree for me. And then I can just use my replace function here. And the interchange assembly lets me swap back and forth between the different versions of that. So here I've got those 3 different components in there, and I can say, hey, let's actually use this tessellated one. You can go ahead and swap that guy in, and it's going to swap out one part and swap in the other part. So again, that's not necessarily related to generative topology optimization, but that's sort of Creo functionality that allows you to take the original design model and then swap that out and swap in a more optimized version of that part very easily. All right, so let's go take a look at this other model that I had open. That's this guy right here. So here's kind of a little bit of a discussion on the bodies and that functionality and how that could be used inside topology optimization. So I've already got a generative design study done down here, but I basically rolled back in time, hopped my time machine and went into insert mode. So I have these things turned off right now. And I have several different bodies here and just kind of wanted to step through that and give you an idea about what that looks like and how you can use that. So here we have the base envelope of the part. So that's my original feature. So here's it basically comes off this feature. So I'll just show you to edit the definition of that. It's just a block, right? And so the thing that's different now in Creo 7 is the addition of this tab for body options. I can go ahead and create a new body at the time I'm creating this base feature, right? So, and I've named it envelope because again, we're just editing the definition of this. But this is going to create a new separate body for me. So I can do that for every single one of the features that I have in my tree. Here we've got an exclude region. So let's go ahead and I'm just going to show that for you. So this is a region of the part that I don't want any of my optimized geometry to be inside this. So it's going to create ultimately sort of a wishbone shaped version of this part. So but I don't want any geometry created inside here. But what I do is I just create that as a regular sketch feature. So again, it's this angled cut here that's kind of removing this top portion of the model. But I have this exclude me right here. So let's go ahead and take a look at the definition of that. So again, it's just a regular sketch feature, and the difference now in Creo 7 is to have this body option, and I created that as a separate volume or part of geometry that I can do other things with. So that's really what I've done is I've just created several of these different pieces of geometry as bodies. So go ahead and turn that guy off. And I've got a couple of other items here. I've got a shaft that I'm going to locate in those two holes. So let's go ahead and show those. We're going to use those too, right? So those are, we're mounting this bracket and we're going to be, putting two shafts in here. We're going to apply different load cases to that. We're going to hold it fixed in this slot region up here. So here I've got the two shafts. Then I'm going to create a preserved body, right? So this is the portion of the model right here that I absolutely want to keep, right? I don't necessarily care about what's going on outside here, but I absolutely need to keep this sort of slot-shaped volume around that hole. So I want to keep that. And I've got two other preserved bodies here. Let's turn those on. Those are going to be the little cylindrical portions of the model that I absolutely want to keep because I'm going to have shafts that are going to be, in those holes that I'm going to be applying a load there to that. So again, those are just created here, standard, Creo functionality as far as sketching geometry and those types of things. And then we have, a couple of other extrude features here that gives me my preserved geometry there and the two sort of cylindrical surfaces around that. So let's go back and show you what that generative design looks like. And I'll turn the bodies off here when that comes back from regeneration. Let's turn off the preserved bodies. And let's see, I don't need that. Well, we'll leave the shafts in there for right now. Let's go ahead and hide the rest of that stuff. Oh, the envelope is the one that I want to hide here. Let's go ahead and hide that. And let's see. I'm going to turn on the preserved body. And here's our resulting geometry. We'll go ahead and show that. So as a result, and I'll show you the loads here too. Let's go back into the applications and see. This is what we ended up with, but how did we get here? So the setup for this, we have, just like we did before, we have the preserved geometry, which is going to be the blue sections. We have our envelope, that's where we're starting from. That's the box that's around that. And the thing that's different here is we have this exclude geometry. We say keep out. Can't have any geometry inside that little T-shaped region of the part. Now, back to the question that came up before, I have a couple of different structure simulations here. I have structure number 1 and structure number 2. So we look at structure number 1, we have the same constraint set as in structure number 2, but the loads are different. Load number 1 is actually, load number 1 and 2 are actually trying to pull apart, like to try and snap that wishbone by pulling the two arms of it laterally left and right. Whereas load number 2, or load case number 2, is actually pushing up on the bottom surface of this, right? So we've got multiple different load cases that are in play, and our optimization looked at both of those when it created the generative design. So again, I didn't step you through all of the pieces, explicitly as far as running that, but all the pieces are the same as the first, part of the presentation that I took you through as far as setting up the starting geometry, the preserved geometry that we want to maintain. And then finally, in this case, we use the excluded geometry and created our optimization from that. So hopefully that more graphically shows the different load cases and how that functionality would work for use in the generative design. All right, last pause here. Any other questions on this?
I don't believe so. One second. Sorry, I had to scroll. Can you add harmonic distortion?
So in Creo 7.0, or the 7.0.0.0, the topology optimization is just structural. But stay tuned, because in 7.0.2.0, they're going to have functionality for both thermal and modal optimization. So I guess the answer is not yet, but coming soon.
And then we have one more. Can you use other parts as excluded geometry?
Yeah, so everything I'm showing here is essentially in part mode, but if you wanted to look at that as far as assembly references and that kind of stuff, I think the topology optimization might need to look to confirm this, but I think it's working just in terms of parts at this point. But you could use other pieces of geometry from an assembly, whether it's copy geometry or things like that, to potentially build bodies around the assembly components and then use that for the optimization. So I think it's just going to be a different way to create the different bodies that you would have inside of your resulting geometry for the setup.
Looks like that's all they have right now.
Okay, some other points to note here, looking at another slide. Again, like I mentioned before, structural optimization right now in 7.0.0.0, thermal and modal optimization coming in 7.0.2.0. And again, this is a new application. You'll find that in the applications portion in the ribbon. You can have multiple conditions per model, different load cases, different design criteria. And you can automatically create the geometry from that using a BREP, or you can keep the tessellated version of that if you like. Some other hardware requirements for doing this: generative topology optimization leverages both the CPU and the GPU for increased efficiency. If you have NVIDIA CUDA-based graphics cards, the minimum of 4 gigs of RAM, you can certainly utilize that. It'll do that automatically, but again, if you have those CUDA cards, that's certainly going to benefit your performance for time it takes to actually create the model. I think that was the other things I was going to mention from that slide. So I will go back to here, do one of these, and do. Oh, of course, it comes up on the wrong screen. Let me do the swap on. Yes.
We had one more. Is this included with CSL licenses?
No, it's a separate license. So Creo Simulate Live, let me go back to here. So what we're talking about here is a different application. So I'm just going to close this and show you where all this stuff lives in the ribbon. So if we go here to applications, the Creo generative design, is a separate application, and that's here, but it's licensed separately from Creo Simulate Live. Creo Simulate Live has its own tab in the ribbon and the functionality that's associated with that. But again, separate licenses that would need to be acquired. Good questions. Any others?
It looks like that's it.
Okay. Well, if there are, I mean, they certainly know how to find us, and that contact us with email or whatever. I'll swap this again, and we've got just a couple more slides. So the whole idea here, right? Getting better parts, decreasing time to market, innovative, cool designs, helping differentiate between yourselves and your competitors. Easy to use, right? So I can create this geometry in the optimization, and then create the resulting final geometry as a freestyle feature that I can do other things with, either 3D printed or machine it as required. Reducing product cost, the idea here is that I'm going to consolidate multiple different parts into one part. So I can create different, decrease my part count and those types of things. So that's the last of the technical pieces. So we have the fun slides at the end.
Awesome, thanks.
So Addison,
yeah,
I'll let you take that. Yeah.
Awesome, thank you. I do not see any more questions in the queue. I just want to thank everyone for joining us today on the webinar. For those of you who are new to this series, I do want to let you know that we have extended our promotion of 50% off eligible Creo extensions. Then this next slide here is a complete list of our Creo webinar series where you can spool up on anything and everything you need to know, such as helpful hints, tips, and how to make the most out of your Creo design environment. Next week, we will be showcasing the add-on GD&T Advisor extension and its capabilities. Now, I'm not exactly an engineer like many of you with us today, but from what I've read, geometric tolerancing, is a widely adopted language used by many nearly half of the world's manufacturers today. And I'm sure this topic is nothing new to many of you, but I bet you can agree with us in regards to the expert guidance if you've used that in Creo to help advance your design workflows. I will be providing a link to the extended supersized Creo promotion in the follow-up email being sent out later this afternoon, along with a link to the complete list of this Creo series. Here you can also find previous webinars from the series if you're interested in watching any of those replays. So please watch your email for that later today. And then to wrap things up this morning, another reminder, there will be a short survey that will appear once we end here. If you have a couple more minutes to spare, we would really appreciate it if you could stick around and answer those questions for us. Thank you again, everyone. We hope you're able to join us next week and have a great rest of your day.